All right, so we're going to start our new unit, which is all about power laws. Half of it's going to be review, half of it not today. And then we're going to continue on with start getting into quadratic relations, which is going to dominate somewhat the rest of the year. So no more linear equations and no more triangles for those of you who don't like them. But again, we're getting into the power laws today. We're going to do 6 of them, four to this class, and then at 10 o'clock we'll do 2 more, the hard ones. All right, so again, today, this first class should be review from grade 9, but again, COVID, I don't know what you did. So again, a power is something that looks like this, where I have, and this is how you say it, 2 to the power of 3. Now, a lot of students say, oh, well, you have a big number and you have a little number. Well, they actually do have names. The big number here is called the base. The little number here is your exponent. All right, now 2 to the power of 3, again, that's how you say it. What it means is if I take the big number and I multiply it by itself, the number of times the exponent is saying. So in this case, I would take the number 2 and multiply it by itself 3 times. So in this case, 2 to the power of 3 is equal to 2 times 2 times 2, which is 8. Now, what we're going to look at, like I said, is we're going to do 6 power laws today. We're going to do 4 here early this morning. Now, the first one is when we're talking about multiplying powers. All right, so when you're multiplying powers, now here's the key, is they must have the same base, the same big number, if you will. All right, so an example of our rule is that we could have x to the power of a times x to the power of b. Now again, when we are using these rules, most of our rules today, they have to have the same base. And so in this case, it does have the same base. It's x and an x. I don't know what the number is, but they do have the same base because it's x and an x. And so what we do is we keep the base the same, but when we're multiplying powers with the same base, we add the exponents. So if I have an exponent a and an exponent b, then our new exponent will be a plus b. All right, so a couple of examples of that. A, we have something like 4 to the power of 7 times 4 to the power of 11. So again, the bases are the same. We have 4 and a 4. And again, if I want to simplify this or express it as a single power, I keep the base the same. I add the exponent, so I have a 7 plus an 11. So I would end up with a 4 to the power of 18. All right, another example, kind of throw a bunch of different scenarios out here, is we have negative 3 to the power of 5 times negative 3 to the power of 8. All right, so again, these powers here have the same base, has to happen, okay? And again, I'm going to keep the base the same. So even though it's a negative 3, the base, and we're multiplying these powers, the base stays the same, all right? So it does stay positive, or sorry, negative 3. Again, I'm going to add my exponents, so 5 plus 8 is 13. All right, a few more here, different, like I said, different scenarios. I could have something like x to the power of 7 times x to the power of 20. Now again, in this case, I don't know what the base is, but I do know that they're going to have the same base of x. So it doesn't matter whether I know it or not, as long as they're the same, which they are, it's an x. I keep the base the same, add my exponents. So I have x to the power of 27. D. Let's see here, we have, okay, a little combination here. So I have x to the power of 3 times y to the power of 4 times x to the power of 4 and y to the power of 10. All right, so I want to figure those two things out. Now, we have 2 different types of bases, but because we are multiplying, you can multiply in any order. And so I'm going to put my x base powers together, and I'm going to put my y-based powers together. All right, so when I look at the x's, if I multiply those two x's, an x to the 3 and an x to the 4, I would have x to the power of 7. Again, keeping the base the same. So I'm combining the parts that have a base x together. Now I'm going to combine the bases with y's together. All right, so I have a y to the 4th and a y to the 10. Again, if I multiply those two, I keep the base the same, add the exponent, so I get y to the power of 14. All right, last one. For this anyways, we'll step it up even more. I'm going to have 6x y cubed times, let's see here, 2x squared y to the 4th. 2x squared y to the 4th. And I'm running out of room here. All right, so now this particular term times a term, we are multiplying. They each have 3 parts. They have a number in front of them. They have a base of x exponent or power, and they have a base of y power. But again, what I'm going to do is multiply them in the order. So I'm going to multiply my numbers together. I'm going to multiply my powers with base x together, and I'm going to multiply my powers with base y together. All right, and so if I did my numbers, 6 times 2, because they're numbers, I am just going to straight out multiply them. So 6 times 2 is a 12. All right, now I have an x times an x squared. Now, if you have an x, there's a secret 1. I always call it the secret 1's of grade 9 there. There is an exponent there. It is a 1. We just don't usually say that. It's like if somebody asks you how much money you have in your wallet. I have $5. That's what you say. You don't say, I have 5 to the power of $1, right? So you don't include that exponent, but it is there. And so if I have an x to the power of 1 times x to the power of 2, again, I keep my base the same, add the exponent, so I'm going to have an x cubed there, x to the power of 3. And then, of course, I do my y's, where I have a y cubed times a y to the 4th. Again, keep the base the same, so that's a y there, run out of room. 3 plus 4 gives me the 7. So our final answer, again, we're having 3 parts. We have a number, a power with a base x, and a power with a base y. So we have 12x cubed y to the power of 7. All right, so that's multiplying powers. And of course, if we're doing multiplying powers, you know, the next one's got to be dividing powers. All right, so move that off here. All right, so let's see here. Like I said, next rule, because we're doing four in this class. All right, whoops, dry that off. All right, so rule number 2, like I said, is dividing powers. All right, so something that we could have is x to the power of a divided by x to the power of b. And once again, as I was saying, just like the last rule, you have to have the same base. Otherwise, you can't do any of this stuff, all right? You can't use these rules. Now, when we multiply powers just now, we added the exponents. So naturally, when we're dividing powers, we're going to subtract the exponents. But of course, as I said, keep that base the same. Now, when you're subtracting the exponents, you take the numerator exponent minus the denominator exponent. All right, so we're going to have an a minus b there. All right, so again, work with some examples. So we get something like 8 to the power of 12 divided by 8 to the power of 5. All right, so again, bases are the same. We got 8s here. All right, so I'm going to keep that base the same. Subtract my exponents, so a 12 minus a 5. So we have 8 to the power of 7. All right, again, I'm going to throw different scenarios at you here. B, we could have negative 4 to the power of 13 divided by, of course, negative 4 to the power of 3. All right, so this time we have a negative base. but it doesn't matter. We have two negative bases because they're the same, which we need to happen. So again, I keep my bases the same. So nothing happens to that negative sign. And then I subtract my exponents. So I have a 13 minus a 3. So I'm going to end up with a negative 4 to the power of 10. All right. Let's see here. C. What do we got? X to the power of 20 divided by x to the power of 9. All right, again, I don't know what the base is, other than the fact that it's x. I don't numerically know what it is. But again, they both have an x for a base, which I need to happen. Again, I'm going to keep my base the same and subtract my exponents. So 20 minus 9 is 11. All right, one more. Let's see here. We have something like x to the power of 8 times y to the power of 7 divided by, let's see here, x to the power of 5 and a y. All right, so again, we have a term on the top that has two different bases, but we also have a term on the bottom that has two different bases. But again, if they have the same base, I can do divide those powers. And so I'm going to divide the base x parts, x bar powers. I'm going to divide the y base powers. All right, so the x part here, again, keep the base the same. So I have the x. 8 minus 5, that's a 3. Now the y parts. Again, keep the base the same. Subtract my exponents. And again, so I have a 7 here. You don't see anything here. It's not a 0. It's a 1. All right, so 7 minus 1. We have x cubed y to the power of 6 is our final answer there. All right, so that's dividing powers. Number 3. Number 3. Instead, do 4 here. So example number 3, or rule number 3, is when you have a power of a power. All right, so we have, say, something like this, x to the power of a, but then we take that whole thing and do it to the power of b. All right, so there's something a little bit different. Now, we only have one base here, but that's the base we are going to end up with for our answer. So we have a base of x. We're going to have a base of x for our answer. And what happens with this one is that we multiply our exponents. So if I have an a and a b, I'm going to have a times b on my answer for my final power. All right, so a couple of examples. For instance, we get something like 5 to the power of 3 to the power of 4. All right, so when we have 5 to the power of 3 to the power of 4, again, my base is 5. There we go. And then I multiply my exponents. So I have a 3 and a 4, and, 3 times 4 gives us a 12. So we have 5 to the power of 12. All right, B. What else? Probably throw a negative base in there. Yeah, this can look messy. So I have a negative 6 to the power of 2, and then I'm going to take that power of 5. There we go. So it looks confusing because there's brackets everywhere. But again, all you have to do is be able to identify what is the base and which ones are the exponents. So in this case, again, our base is negative 6. All right, and then again, our exponents are 2 and 5, so I multiply those, and so our final answer is negative 6 to the power of 10. All right, something like this. C, we could have y to the power of, let's see here, negative 4, and then take it to the power of 6. Now, this is something we're going to deal with in the next class, negative exponents, but just for this, again, I have a base. It's not a number this time, but we do have it. So I keep the base the same, and again, multiply my exponents. So I get a y to the power of negative 24. Again, we're going to learn how to deal with negative exponents later on today, which you did not do in grade 9, no matter what class you're in, probably. Let's see here. Yeah, that's it for that. All right, so now we go to rule number 4, the last one for today, or for this class anyways. So that's power of power. Now this next rule is probably used the most in math when you're dealing with powers or polynomials, because polynomials and powers are basically the same thing. All right, so this is number 4. This is the expanded that one. Get rid of that guy. Expanded power rule. All right, so here's the expanded power rule. Looks 2 different ways, but essentially the concept is the same. Is that if you have 2 things or more, it doesn't even really matter, but I'm going to say 2 things to the power of a. So there's my 2 things. I have a term, an x and a y. And what the expanded power rule says is that if whatever is in the brackets, if there's 1 thing or 2 things, 3 things, 4 things, the exponent is applied to everything in the brackets. And so I would have to take x to the power of a, and I also have to take y to the power of a. Or you could look at it, now those are 2 multiplying things. Same idea if we have division. So say we have a fraction inside for our base. But again, 2 things are inside the brackets, so the exponent is going to be applied to both things. So I would have x to the power of a and y to the power of a. All right, so the exponent gets applied to everything in the brackets, whether it's in the numerator, denominator, it doesn't matter. All right, so let's try some examples here. First, let's see here. We have 1/5 squared. All right, so there's an example of division. All right, but again, I have a 1 and a 5 in the brackets, right? 1's in the numerator, 5's in the denominator. I'm going to apply the exponent to both the 1 and the 5. And then I can further simplify this. 1 squared, 1 times 1 is 1. 5 squared is 25. So the answer is 1/25. B, we have something like negative 2/3 to the power of 4. All right, so again, we have an exponent there of 4. There's 2 numbers. It's a fraction, but there is 2 numbers that make up this fraction inside the bracket. So I'm going to apply the exponent to both the negative 2 in the numerator and the 3 in the denominator. All right, so negative 2 to the power of 4. So that's negative 2 times negative 2 times negative 2 times negative 2, which would give me, let's see, negative 2 times negative 2. That's a 4 times negative 2 is a negative 8, but times a negative 2 is a positive 16. And then 3 to the power of 4, 3 times 3 times 3 times 3. That's an 81 there. All right, let's see here. C. We got something like x divided by y to the power of 5. Well, that's just like our definition here. So what I'm going to do is apply the exponent of 5 to both the x and to the y. Well, because I don't know what x isn't a number and y isn't a number yet, that's as far as I can go. All right, so I just applied again the exponent to both the numerator and the denominator. All right, let's get into some multiplying ones. So like our first example there. So for example, something like this. We have 2 x to the 5th y cubed. All right, so now I got 3 things inside the brackets. I have a number and 2 different powers. All right, but I'm going to apply that exponent of 3 to the 2. I'm going to apply it to the x to the power of 5. and I'm going to apply it to the y. All right, so that 3, again, exponent 3 is being applied to every single term. Now I can simplify this. 2 to the power of 3 is 2 times 2 times 2, which is an 8. And then I have x to the power of 5 to the power of 3. That is a power of a power. So what happens with these rules is we're going to be able to use more than one rule for some of these. And so when I do have a power, again, base stays the same, multiply my exponent, so I get x to the power of 15. And well, y cubed is y cubed. All right, so we have x times x, or 8 times x to the power of 15 times y cubed. Let's try another one of those guys. We got 3x y to the 7th squared. Oops, y to the 7th. And we square it. All right, now I'm going to do this all in one step, this one. But again, that 2, exponent of 2 is getting applied to every single term in there. So 3 squared, right? So this 2 is applied to the 3. 3 squared is 3 times 3, which is 9. X squared, well, x squared is x squared. All right, and then the last one, again, I'm going to take y to the 7th and square it. That's a power of a power. So again, I keep my base the same. I multiply my exponent, so I get y to the power of 14. All right, now, like I said, we can have questions where we have to use a bunch of different rules. Not all of them, but more than one. So I'm going to try do a few of those. We call them combos. So it's applying more than one rule to a question, which we kind of just did right here. We use the power of a power. And that will happen again today at 10 o'clock when we use negative exponents. All right, so these questions, again, I'm going to call them, whoa, that's wet. So these are combos, I guess. All right, so we have something like, and again, the question always says, write as a single power. So simplify it. So I get something like this, 5 to the power of 10 times 5 squared to the power of 3. Oh, and then we'll throw a division in there, 5 to the power of 4. There we go. So again, the key here is I can use a lot of these rules because the bases are the same. Now I want to simplify this, and there's a lot of different ways you can do it, but you're a little bit restricted. I could divide these two here, but what I'm going to do is I'm going to simplify this part here, this power of a power. And so I got 5 to the power of 10 times, and again, power of a power here, keep the base the same. Multiply my exponents, so I'm going to have 5 to the power of 6 there. And again, divide by 5 to the power of 4. So I did a power of a power here. On the top, I'm multiplying my powers. So that's rule number 1, keeping the base the same. I add my exponent, so I get 5 to the power of 16. And then finally, now I'm dividing powers, rule number 2. So we're going to use 1, 2, 3 here. Keep the base the same. And again, subtract my exponent, so 16 minus 4 is a 12. So we just used 3 rules there, all in one question. All right, let's try it again here. Try something else. We got 4 to the power of 8 to the power of 4 times 4 to the power of 7 divided by, this one's very similar, 4 times 4 to the power of 3. Again, a lot of parts here, but again, I'm just going to simplify where I can. All right, so again, rule number 3 here, the power of a power. I can figure that part out where I keep the base the same. Multiply my exponent, so 8 times 4 is 32. And again, times 4 to the power of 7. All right, so there's my numerator. I just figured out this part. Denominator, I can do some figuring out there because I have a power times a power. Same base, of course, needs to happen. I have a 4 here again, that exponent, secret 1 there. And so if I put these two together, I have 4 to the power of 4. All right, and again, just like I did up here, I can do it a little bit differently. It doesn't matter. I can either put these two together or take this into account. So I could actually divide these two here if I wanted. That's one way to do it, but I'll stick with what I did up top, where I've got my power times the power here. So I'm going to, again, keep my base the same. Add my exponents of 32 and a 7. Ooh, that's 39. And of course, down the bottom, I still have that 4 to the power of 4. And then once again, dividing powers, same base. Keep the base the same. Subtract my exponents. So 39 minus 4 is a 35. So I end up with a 4 to the power of 35. So there's an example there where we used all the 3 of the rules in combination just to simplify it and get down to, again, a single power. All right.